Good evening, everybody. It's July 1st, 2021. It's Azure Thursday. And Esther, they did it. They are letting us host, the two of us.
Yeah, who made that happen?
Well, somebody decided it was a good idea, so here we go.
Well, I think it's a good idea. After the last time I took over the show, it's good to now have a co-host right from the beginning. So I'm really enjoying teaming up with you, Roel.
Yeah, I heard it was also appreciated that when you joined the time before last time, you introduced one of the guests as your what was it, your swag swindler or something like that.
I remember that one too. Yeah, I'm very good at introducing our presenters. Yes, maybe that's something I need to work on just a little bit.
I think you're doing fine. So today we have 3 presenters actually. The first session will be 2 gentlemen, and I guess I'll just let you introduce them.
Yeah, sure. Let's bring them on. Tech support. And so hi guys.
Good evening.
Hi.
Yes, I guess I need to confess that Patrick and I do have a small history together. But I'm very excited to have Patrick and Rick join us tonight to present the cool work that they are doing on what I like to call transitioning from traditional admin roles to a more DevOps focused role. And I guess not everyone is aware that Patrick and I have a history in end user computing. And I think for us, well, maybe it's just me, but I think at least the way I see it, end user computing was one of the pioneers that already realized that if we want to transition to a cloud, we needed to adapt automated deployments, automated configurations. So how did that work for you, Patrick?
Yeah, for me too. And when it started eventually with automating installation when I was a small kid in the XP time, then I just bought 2 CD players, and when somebody in the street has a problem with his computer, they just bring the computer and I just put the CDs in. So it will automatically install the computer of my neighbor, and then I can go to the gym while installing that and earning $50.
Nice.
So that knowledge I bring into the end user computing by just building golden images. And yeah, it was be a mentality for me, like if I need to do it twice, I automate it because I'm lazy by nature. And yeah, now we're doing with Rick a very cool Azure DevOps project in the end user computing space. And then I also realized that, wow, when doing end user computing, you also touch a lot of components. Like we're operating in the 6th layer of the OC model, in the presentation layer. And if you do everything, you need to automate from networking towards desktop delivery, and how a user is opening Outlook. So yeah, that's really cool.
That's awesome. So, one of the things that I learned in the short history that I have with Rick is that he not just focuses on the technology, but he also takes the processes and the learning or the journeys that, well, traditional admins have to make to adapt to new technologies and new automation styles, new skills, new competences. So I really love seeing you in action, Rick, or feel privileged that I get to see you in action in motivating and getting the team enthusiastic about these new cool things to explore. So how do you feel about that?
Yeah, it's a steep learning curve. And I'm glad you're on board now. So yeah, we haven't worked a lot together yet, but I'm sure the future will bring us a lot of fun. Yeah, and I see there's a steep learning curve for people, and I think if you understand the process, then the technology is second. Then it doesn't matter in what method or how you're going to do it. If the process is good, then yeah, the technology will follow, and the end result will be there.
Yeah, adaptation becomes easier if the processes are in place.
Correct. Yeah.
That makes sense.
Yeah.
Well, with that short introduction, because I know you added at least one slide in the presentation on introducing yourself, all I guess that's left to say is, guys, take it away, and we'll meet you after the presentation for some Q&A.
Thank you.
So I will start the session. So welcome everybody to our session about deploying Windows 10 multi-session with Azure DevOps, Terraform, and Packer. And Rick and I decided to make this session since we had a steep learning curve moving away from a traditional sysadmin, which are doing end-user computing, to a modern approach via Azure DevOps, Agile, and Scrum. In this presentation, we have a lot of topics which are a presentation itself. So our goal of this presentation is to give you an overview of all the possibilities, what you can do with Azure DevOps, Terraform, and Packer. So you can start with it from the beginning, because there is a lot of new things to learn if you start with this new approach. So first, let's introduce myself. I'm Patrick van der Born. I'm an independent consultant and architect in the Netherlands. I'm also active in the community, and I'm very proud that Citrix rewarded me with the Citrix Technology Professional title. I'm also known and member of Team RGE. That's such a bunch of GPU nerds. So we're doing things with the GPU. I'm also a member of Go AUC, and basically there I'm also automating the lab deployments and doing a lot of public cloud researches for performance of end-user computing. If you want to reach out after this session to me, you can just send me an email, follow me on Twitter, contact me on LinkedIn, or start reading my blog. And I will give it to you to my partner in crime, Rick.
Yeah, thank you, Patrick. My name is Rick Stijman. I work for one of the big Dutch banks. Yeah, you see my Twitter, LinkedIn, website, and email as well on screen. I don't have a lot of other titles than that, but I will take over the presentation. Yeah, we have an big agenda. I'll take you to the journey to a DevOps Scrum approach. And then we'll give some context about Windows 10 multi-session with Azure DevOps pipelines, and Patrick will have two interesting sessions about infrastructure as code and image as code, and of course we're open for any Q&A. So speaking about our DevOps journey, so I work at a large organization, and back in the day, 2019, we started basically within our organization with DevOps teams, and that meant basically that we put the developers and operations together, and we called it DevOps. But then we found out that that was not enough. Yeah, and then we improved that by adding Scrum Masters, product owners, have a team backlog, and really adapting the Agile and Scrum framework. And 2021, we started with a real DevOps journey, and it's still ongoing. And if we speak about DevOps, traditionally, especially in a big enterprise organization, what we have seen in the past is the way we did it is that we basically gave always an engineer a task or a group or a team. And then we let that engineer start to work in a dev environment, because you don't hit production once. And then you start developing basically in the GUI. And once he was happy with it, he started in a UAT or an acceptance environment, and doing all the work all over again, and then bring it to production. That's basically, in a nutshell, the way we did it for years, which was fine because we were really good at it. No issues with that. But yeah, it's not really efficient if you look at the process. If you look at how we do it in a DevOps way, then basically all those environments are logged in code, and we have got create one configuration file, and the parameters are from the Azure DevOps repository brought to the environment via a pipeline, and that means less work for that admin. So basically, if you look at the admin, the way how he works will change. So basically, from using a GUI and logging his changes in an ITSM environment, using a file with a copy of a copy of a copy, going through all the stages by hand, then his work will change, because we ask now that engineer to change that way of working by moving his work to an Azure DevOps repository, because we have a philosophy, everything as code. So that engineer is coding, and that pipeline is taking over his work by logging the changes and going through the environments. And of course, one of the big advantages, what I see in we use Azure DevOps, and there are different DevOps tools around, but yeah, we're locked in with Microsoft in this one, is the test plans. So we basically go through all the stages as soon as the tests are passed. So why are we doing it? Because I said, yeah, we've done it before in the old-fashioned way. Why are we doing DevOps now? First, we want to automate everything, but also, if you do it good, then you have a faster delivery of that configuration, and by using code, the quality control of that configuration is higher. It's less repeated work. So you type it once and then it goes through the environments, but gives less issues, what results in less calls on the help desk, less ad hoc work, but it has had impact on the team. And I've seen it myself, people working 15 years in IT, 20 years, even more. Going from GUI based to coding it's a big change. It fully integrates with Agile, and we are really focused on the process instead of doing the ad hoc work. Basically, you want to go from sometimes I say from DevOps to NoOps. But one of the things is, if it's a steep learning curve, if you do this, then you have to make mistakes, and by those mistakes you can learn and improve. And that's something we see in our teams every day, who are adopting this way of working.
We never make mistakes, Rick, right?
Yeah, that's for us.
It's for us.
Yeah, that's for us now. That's a question when I have a lot from what is this pipeline? What is code? Now, basically, if we talk about a pipeline, and you will see it later on also in Patrick's videos, it's basically a set of jobs written in a YAML file, and the goal is to build a code as described as it is in the repository, so our source code, and it's basically delivery of the configuration.
Yeah, Rick, and this is also a slide, and we added this in because when I started at the Rabobank, you had a funny story, and I was also a traditional sysadmin, and maybe it's worth to share it with the audience here about how you deployed your first network on Azure.
Yeah, that was basically one of my first touches with Azure DevOps. I was tasked to get an VNet in our subscription, and we have a big cloud competence center, and basically they do everything DevOps. And I went to one of those network engineers and I said, hey, can I get a VNet, connect it over Express? And basically said, yeah, you can go to this repository and then you fork it, and then you change, and then you do some commits in the parameter file, and then you create a pipeline, and then you build that, and then it will be delivered. And I was like, okay, I'm working for a long time in IT, but what's this? What did I miss? Which train did I miss? Yeah, and then he laughed at me. And he left a few times, and he said, "Okay, I will show you what I mean, and I will show you what how this works and what I mean with all those terms." And then basically, I was forced in this way of working because the other part of the organization was already doing this. But a lot of those terms now on the screen, like cherry picking, pull, pass, was all new to us. And nowadays, if you hear our daily stand-ups, for example, this is common terminology now.
Yeah, I think we mention each word multiple times a day here now. So
yeah.
It's a bit funny.
Yeah.
So basically, and also for me, the DevOps journey started here from a traditional IT guy. And to give you some context about our project, we are tasked to deploy a Windows 10 multi-session environment via Azure DevOps pipelines on Azure. And basically, in our project, we defined 3 sub-projects. We call this pillars. So the first one, and that's the lowest layer of the LC model, is infrastructure as code. And we're using HashiCorp Terraform for this. And since we're using Citrix as our brokering platform, we deploy, for example, our Citrix Cloud Connectors, which are Azure VMs, and also the Azure NetApp files, our networking, key vaults, and our shared image gallery via HashiCorp Terraform. The second pillar in a project is image as code. And for image as code, we're using HashiCorp Packer. And we're tasked to deploy our images on multiple platforms. So we still have VMware vSphere on Windows Server 2019 in an on-premises data center. So we can use published applications which are only allowed from our own data center. We are also able to make images for Microsoft Azure, Windows 10 multi-session, which is based on the AVD images. And in the future, we're digging in to deploy our images on Amazon AWS, where we can do a Windows 10 single session for our developers. The third pillar we defined in our project is desktop as code. And with desktop as code, we're describing the Citrix Cloud configuration as code, and we're using for this PowerShell, APIs, or the Citrix automated configuration tool. And basically, we're configuring there is the Citrix virtual apps and desktop service, but also resource locations, zones and machine catalogs, etc. But I think if this is not an end-user computing thing, this is the boring pillar. If you want to do Azure Virtual Desktop as code, that's also possible, and you could use HashiCorp Terraform for this. There is a desktop virtualization provider and resource you can use, but you can also use PowerShell. When I started this project, my tool set expanded a lot. So the green boxes are the only boxes I knew when I started the project, but these are the tools we're using daily. So basically Git, which will check in and check out the code, and it's integrated in Visual Studio Code. We're using Azure DevOps, so repository, pipelines, and self-hosted agents. We're also using the boring stuff, which I don't noted in the presentation, like boards and all that kind of stuff. HashiCorp Terraform, Packer, PowerShell, Citrix automated configuration tool, and Azure Key Vaults. So this is our tool set we're using on the project. If we look at the context of our project, I think at first we want to onboard 4,500 users around the globe. We now deployed the first users in Australia, and we're now busy deploying it in Europe. And I think at the end of the year, we will start in the America region. The goal of this project is to do everything as code. Using Azure DevOps pipelines, and in our project, it's mandatory to use YAML pipelines. Since we need to save everything as code, the YAML pipelines are stored in an Azure DevOps repository, and they are source controlled that way. If you're using the GUI, then your pipeline is not source controlled. So that's why we're not allowed to use GUI pipelines or release pipelines, since release pipelines, you cannot specify them in YAML. The last project, the project goal is that we have zero-touch interfaces. So our sysadmins at the end don't have admin rights in Azure, and also no admin rights in Azure Citrix Cloud. So it's mandatory for them to change things via code. So everything is logged in the pipeline log, for example. So let's dig in to the first technical stuff with Terraform. And if you never used infrastructure as code, then it's very handy to know the difference between a declarative approach, and that's basically what Terraform is, and an imperative approach, which is basically as a scripting language. So with a declarative approach, the programmer specified what is to be computed. So for example, I want a hamburger with bacon, onion, and barbecue sauce. So if I specify it that way, the system will automatically detect and know what to do to give you a hamburger with bacon, onion, and barbecue sauce. And on the other hand, Terraform is also having an idempotent approach. So if I ask it multiple times for a hamburger with bacon, onion, and barbecue sauce, it will detect I already have one and tells me like, hey, Patrick, you have to watch your calories. You already have one hamburger, so I won't give you a second one until you finish your first. If we look to an imperative approach, then the programmer will specify how it's to be computed. So for example, you have to define the whole flow. So are there hamburgers? If so, get it, put it on the fire, wait until done, etc., etc. And also the things in the flow when it's go wrong, for example, if it burns or the fire is too hot. So in my perspective, if you start with infrastructure as code, it's way easier to start with a declarative approach, because you can specify more in what you want and not how to get it. When we started this project, we also did some software selection. And since the first platform to use is Microsoft Azure, we make a comparison between different tools. And we've selected HashiCorp Terraform over Microsoft ARM, or nowadays Bicep. And basically why we selected Terraform is that we have a dependency of a multi-platform support. And if you want to use Microsoft ARM or Bicep, then you have a Microsoft login, and this is only used for deployments on Azure. And since, for example, we also need to deploy things on vSphere or maybe later on AWS, it's also good for our engineers that they only have to learn Terraform to deploy resources on those multiple platforms. So they are not getting bored about, okay, if I want to deploy something on Azure, I need to learn ARM or Bicep. And if I want to deploy things on vSphere, I need to dig into the VMware Power CLI. Both is a declarative approach, and you can use both for redeployment. And basically, if you look to ARM, the first time I tried to understand ARM and to create an ARM template, it took me about 1 or 2 weeks, and it's a massive JSON object. And the first time I've deployed a virtual machine on Azure with Terraform, I was done within 1.5 hours. And I was thinking like, wow, this is like magic. And I think Microsoft is also getting this, and they created a very cool tool, Microsoft Bicep. And Bicep is basically in my opinion, it looks a lot familiar as Terraform, but it generates ARM, those complex ARM templates for you. Another advantage from Terraform above, for example, Microsoft Bicep, is that there is a plan stage. And a plan stage, you can see it like some kind of what-if scenario. So if you've declared all your resources in code, you can do Terraform plan, and Terraform will tell you what it's going to do. Like, I'm going to destroy 3 resources, I'm going to add 2 resources, and I'm going to change these resources. And if you're okay with that, then you can apply the configuration to the real world. Yeah. If you want to use Terraform, you can just go to their website, and this is just a quick screenshot of some of the providers they support, and there are a lot. So they basically support AWS, Azure, GCP, Oracle, Alibaba, and you can even deploy things on Azure Stack or in your Active Directory. And for us, it's also for VMware vSphere. The documentation of Terraform is very good. So if you just click a provider, and maybe this is a little bit small, but on the left-hand side, you see all the services on Azure in this case, which you can deploy with Terraform. So if you want to deploy a CDN or container services, you just click on it, and on the right side, you get examples of all the resources and parameters you can define for that particular resource. And normally if you go to the documentation and you want to deploy something, you're finished within literally some hours. If you do desktop virtualization like Azure Virtual Desktop, there's also a desktop virtualization provider, and then you can deploy resources for Azure Virtual Desktop. So in this case, a virtual desktop host pool, which is the equivalent of the Citrix machine catalog. So you can just specify it this way, and then it will create a host pool for you on Azure. Terraform is using the HashiCorp tool language, And basically it's very easy to configure. So this is an example of deploying an Azure Windows virtual machine on Azure. So basically first you define resource, then what resource. On this type it's Azure RM Windows virtual machine, and you give your object a label. So in this case, my first Azure virtual machine. And then you can specify all the parameters for this resource. So you have to give this virtual machine a name. So my first Azure VM, and you need to specify in which resource group the virtual machine will live. So in HashiCorp 2 language, you can make reference between the different resources you want to deploy. So for example, on the right-hand side, if you defined a resource group resource with the label main, and you give it a name and a location in West Europe, you can reference it here, like Azure RM resource group, what's the type, dot the label, so this is main, and dot the name. So it will automatically fill in the name here. And the same is here for the location. So if I change my code, for example, the location to North Europe, then this virtual machine will pick this up automatically, and I don't have to change this on multiple lines. So this makes the coding and describing your resources in Terraform very easy. If we go down here, we specify the size. So this is an F2, an admin username and a password. This is not the way how we do it in code, but it's okay for the example. And we're building from a marketplace template in this example, 2016 with the latest version. And we specified an OS disk of HHD with the caching and read-write mode. So this is all the code you need to just deploy a virtual machine on Azure. And because this session is not 2 hours long, so I ripped the Terraform demo out of it. But in the end, if you deploy this amount of code, the end result is just a virtual machine that everybody knows on Azure. So it's as simple as that. If we dig into the images code with Packer, so we basically want to build an immutable image. And again, we started to start with the tool selection. And since our first images are on Azure, I want to compare we selected HashiCorp Packer. Like HashiCorp Packer again has a multi-platform support, and the Azure Image Builder has a vendor login because it's Azure only. And with HashiCorp Packer, we can deploy our images on Azure, AWS, and vSphere, like one of our project goals. One thing is images code, both are images code, so you can describe your images as code. And maybe I defined they're simple and complex. So this is simple, and I think simplish. Like Azure Image Builder is like an umbrella around Packer. It also used Packer under the hood. And I was thinking like, hey, Packer is so simple. So I think, how can you make things even more simple? And I dare to say, but unfortunately, this is not an in-person event when we can drink a beer at the bar and discuss this, is that maybe Packer is a little bit easier to handle than the Azure Image Builder. Again, we're using the HashiCorp 2 language here. So that's also easy for our admins. So they just need to learn one language to deploy infrastructure and images. And basically, if you want to define a Packer template, which is basically your image description, we have 3 sections. So the first section is variables. That's where we declare all our variables. So in this example, it's an Azure AD application ID with the type string, and in this case, a default random value, and a source, which is the Azure Image Builder. And later on, more. So basically, this is the machine which will create the image. And here I make a link to the variable. So the client ID for the Azure Image Builder has a link to var.aad underscore application ID, which is this variable. The third section is actually the build. And I explain this more like a task sequence. Like I'm more from a traditional world where we use, for example, Ivanti automation, SCCM, or MDT, and see this like a task sequence. So basically, the build first is sources, so where to build it. So this is on Azure. And the other ones are provisioners. So basically, this provisioner is executed first, which is actually a PowerShell script with just the right verbose, and a provisioner of file, which actually uploads a file to the image. And when the build is done, that's your image. But I will show you a demo of this later in the session. So some terms of Packer, and the first one is a builder. So a Packer builder is actually a machine, a temporary machine, which will build the image. So here is that guy who's controlling the buttons, and you can build this on multiple platforms. So on the left-hand side, there are the most common. So Ali Cloud, Amazon, Azure, GCP. You can even do it on premises, on Hyper-V or Nutanix or VMware vSphere. And you can start with it if you want to start with it today on your own machine for free to just install VirtualBox. And then you can just download the packer.exe from the website, and you can start building images on your laptop. There are also a lot of other platforms I don't know. That's on the right-hand side. Maybe there's one you're using. But hey, I'm a Citrix guy, and there's also support for Citrix Hypervisor, also known as Sans Server. If we dig into the provisioners install and configure software on that build, on the temporary builder as a task sequence, as I also mentioned in the HashiCorp tool language example. So for if we are deploying a Windows image, these three are the most used provisioners: files for up and downloading files, PowerShell for executing PowerShell scripts, Windows Shell for executing command line, and if you need a reboot after installation, you can just insert the Windows restart, and then Packer will wait until the builder VM will come online. If you do Citrix, for example, it's also a possibility to deploy Linux VDAs, so Linux workers instead of Windows, and you can also use Packer to build your Linux images. And if you're more into other tools, we're now looking into Ansible. That's a declarative approach of, for example, installation. You can also deploy an Ansible playbook with Packer. So Packer will just execute the Ansible playbook, and that's the end result of your of your immutable image. But hey, if you're more into Chef or Puppet or Salt, then you can also use that. If we look to this example, we just basically install 3 applications via PowerShell provisioner. So basically first FSLogix is installed, and when it's done, it will install Office 365. And when that's done, it will install the machine-wide installer. With Packer, we can also give some environment variables to watch the execution. So those environment variables with their values are available during script execution on the builder VM. And we can specify the context of where the script is executed. So if you need to execute an installation script in a different context, you can just specify the username and password over there, and the script will be executed in that context. From a pipeline and a CI/CD perspective, we are passing lots of pipeline variables to those environment variables and context execution, so we can make things dynamically build up over there. So that's a possibility to link them. The end result when everything is done will be, in this case, an image on Azure, or it's a managed image, an image in your shared image gallery, or for Citrix, we still need to have a VHD on a storage account. And that's just how you specify the outcome. And I now will show you a pre-recorded demo of how to do this, so you can see this in real life. And I think my colleagues will now send you a text message in the chat. So if you're in a region or on a link where the connection is bad, or you see artifacts, you can see this demo movie on YouTube after the session, or maybe now if you want to switch.
Welcome to my demo of creating a Citrix master image with Packer via Azure DevOps pipelines. So at first we want to connect our Azure repository to our local Visual Studio Code so we can edit files. When you go to Azure DevOps, you can click your project. So in my case, this is Born IT CI/CD Desktop. Within here, you can go to repositories and files, and here you can find the repository of our image as code. And in this repository, all the files are stored describing our image. So for example, the Packer template or the installation script or the YAML files for the pipeline run. So if I want to edit this in Visual Studio Code, I just click clone, then clone in VS Code, open, and Visual Studio Code will ask me, I really want to open this URL. I said, okay. Select a location where the repository is stored locally, and Visual Studio Code will use Git to clone the repository to my local storage. So when I press open, I can see the files in Visual Studio. So that's very easy. Let's first start investigate the Packer templates, which are actually my image description. So within the Packer templates, I defined two templates, Win10 multi-user for Azure and Windows Server 2019 for vSphere. So if you look at the files which are in the template, there are actually 3 HCL files. And HCL stands for HashiCorp language, and those files are stitched together when doing a Packer build. So let's first dig into the variables file. So in the variables file, I declared all the different variables used by the Packer template. So for example, the Azure AD application key and the Azure application ID, which is actually connects to my Azure tenant. I can mark some type of streams as sensitive by specifying sensitive is true. And when I specify the sensitive is true, the strings are not logged. So they're just replaced by stars. So the application key, for example, is not exposed in a log. If we look at the Packer template itself, you see these two sections here. One is source, which is actually the description of our Packer builder, and build. This is actually the task sequence of provisioners, which will in the end be our master image. So if we look to the source, so this is the Packer builder, I specified here Azure ARM. So if we look to the vSphere builder, I can specify, for example, here vSphere ISO to specify a vSphere build via an ISO file. As you can see here, different parameters are needed per builder type. So in this case, I need to define the cluster where my builder VM is deployed. And if I look to the Azure, I need to define the resource group where my builder VM is deployed, for example. When building a Packer image on Azure, it's very important not using a public IP. So if you enable this, a public IP will be attached to the builder VM, and you can publicly connect to Windows Remote Management. And I think you don't want that. And as you can see here, all the parameters are linked to a variable. So in this case, it's the AZVM image offer. Those variables are specified in the pkr-vars file. So for example, for this image, an Azure virtual machine size of B2MS is deployed in West Europe. If we look at the build, then we see here that it's using the builder on Azure, like the source. This is what we say seen above. Azure ARM, Windows 10 multi-user Born IT AZ. This is the label over here. When starting the build, Packer will first execute this provisioner. This is just an inline PowerShell script installing Chocolatey. Then installing 7-zip via Chocolatey, Notepad++, and build a manifest file. So we can use this, for example, as an artifact, so we know where the VHD is stored after the build. In my build, I specified the most variables for my builder in a pipeline. So for my pipelines, I specified a Packer builder vars file. And here I specified all the information used by the Packer build. So for example, my subscription ID, application ID, my builder temporary resource group name, which will be actually RG Packer build. And when the build started, with the build number as a postfix. And some variables are retrieved from the key vault. So I specify them here as retrieved from the key vault, so that I do not have to specify this in code and store this on my repository. When you look at the Packer job and we look at the Packer build, you see here that I specify during the build all the different parameters from the pipeline to a variable which we declared in Packer. So for example, the Azure AD application ID, this is the Packer variable, and this is my pipeline variable. And I also uses the pkr vars HCL file of the template as an input. So this was the file where we specified, for example, in which location the builder VM is built, or what type of marketplace image is used. This was this file. So okay, let's deploy this image to Azure. To deploy this image on Azure, we go back to Azure DevOps. And since we specified not using a public IP for our builder, it's mandatory to use a self-hosted Azure DevOps agent, since we need to have a network connection to the private IP of the builder VM. And the public Azure DevOps agents from Microsoft cannot connect to your private IP addresses. So when you go to project settings, agent pools, we see an agent pool here, which is Windows Azure MPN, which is hosting my Microsoft Partner Network subscription. And if we look to the agent, I just installed it on my WVD session host, and it's up to date and it's online. So I can use this for my pipeline run. When you want to run a pipeline, we just go to pipelines. We see here Azure Windows 10 multi-user Born IT Azure, and I simply press Run Pipeline. So these are the parameters which I specified on the YAML pipeline, and yeah, these are correct, so I can just hit Run. Now the pipeline is starting, and you see it's a multi-stage pipeline. So the first step is to actually create the image, and the second step is to copy it to the right location. And now the build is started, and I will actually go to the point that it starts creating the image. Okay, the actually build is started. As you can see here. Here is the output and the logging of the Windows 10 multi-user Azure Packer build immutable image. So as you can see here is that the temporary resource group is created called RG Packer build Windows 10 with the build number. So you can see here the build number, and which is actually the build number of the run. The location is West Europe, and it's now creating temporary resources in Azure. So let's switch to Azure. So if we go to resource groups, we're seeing the same resource group here. As you can see, Packer created temporary resources in the temporary resource group. You can identify them with the prefix of PKR. And the rest of the names are generated by Packer. So every run, the PKR virtual machine will have a different name. So it generates a virtual machine with a corresponding network card and a key vault. And in the key vault, a certificate is stored to connect securely to Windows Remote Management. Packer will delete those resources when it's done with the Packer run. So it's still creating an image, and as you can see here, it's installed Chocolatey, and it's now installing Notepad++ and 7-zip. So it's downloading 7-zip and installing it to the image. As you can see here. So the Packer build has finished. It took about 13 minutes to build the entire image. As you can see here at the end, the Packer builder is shut down and it's deleted from Azure. At first it captured the VHD from the builder VM. So if we go back to Azure and we go back to resource groups, we can refresh here. And we are seeing here that the default the temporary resource group is removed. If we look to our images in our containers, images, I see here the most recent image, which is Windows 10 multi-user Born IT Azure, and it's the 18th build of the image. So these images can be deployed to our virtual machines in Azure with Citrix Machine Creation Services. So we now deployed our image on Azure, and if I run the pipeline for vSphere, it will actually do the same process, only then on vSphere. Like it's now giving us the output on vSphere, and it created a VM called Packer with the Packer run number in it. And when this Packer build is done, you can use a snapshot of this image to deploy this with Citrix Machine Creation Services, or maybe you want to make a provisioning service image of this, so you can deploy it with provisioning services. Well,
to wrap this Packer build up, I try to made a diagram of the whole process with Azure DevOps. So basically, we started first defining our image and all our install scripts of that used by that Packer template in our Azure repository, so we can source control it. Then we're using a pipeline to execute everything on an Azure DevOps self-hosted agent, which can access the private IP later in the process. So the Azure DevOps self-hosted agent will download the repository and then install Packer. So it can actually use Packer, and it will use the specified Packer template. So in this case, the Windows 10 multi-session. Based and specified in the Packer template, a temporary builder VM is created. So in this example, it's on Microsoft Azure, but it could also be on other platforms like VMware vSphere. When the temporary builder VM is ready, the provisioners are executed on the builder VM, and the PowerShell scripts are executed over there. You could use the Evergreen module, Chocolatey or Winget to get the latest and greatest install script. So your CI/CD Evergreen, and we are using, for example, Azure files to store our exe and MSE files, which we are installing on the Packer builder. If you want to save and also source control things which are in here, you can save file hashes to your installation script, so you can check it if the executable or the MSI file on Azure files is still the same. So when the Packer builder VM is successfully done, all the provisioners in the build, so the task sequence is complete, then the temporary builder VM is shut down. The VHD or image is copied from the temporary builder VM to a shared image gallery or your VHD in a storage account, and then the builder VM is removed from the Azure environment. So this is basically the whole process of building an image as code via Azure DevOps using Packer. And after the summer break, I will make a blog and put everything on GitHub, so you can also see the scripts. So this is the end of our presentation, and I want to say thank you, and also for Rick. And if there are any questions, please reach out to us. Or I don't know if there are any questions right now.
Yes, we have noted down some questions.
Cool.
So I'll kick off because I know Roel is also dying to ask his questions, but ladies first. So yeah, I guess that's me. So the one question that I do have is, at the beginning, you said that you both know that there are a lot of different tools, different DevOps tools, methodologies to get to an end goal, like your as code goal that you have. Do you think that it's important to pre-select some standard tooling within your project? Or do you feel DevOps methodologies are flexible enough to do like a bring your own tools for engineers that are building the CI/CD pipelines?
Good question. If I'm doing this, the most code you're writing is common. For example, your infrastructure as code in your Terraform script. So you can easily transfer that, for example, from Azure repository to a Git repository, so that it's not a problem. So I think you just need to select the tools which you are familiar with and which is the best for your project goals. And if that's Azure repos with pipelines, that's okay. But you can also use, for example, Git with GitHub Actions or Jenkins. And as what I've learned now, I've seen a lot of demos about Jenkins, is that if you know the flow about building your infrastructure via a pipeline, and you get used to use Jenkins, you can just translate the Azure DevOps pipeline run to a Jenkins pipeline. And basically, yeah, it looks different, but it does the same.
Yeah, that's true. And as to add to it, it also depends on the organization. If you're a large-scale organization and you adopted Azure DevOps, for example, then it's easier between teams that engineers move across teams and using the same tools, so that you standardize in that way. It's good to have teams have their own tool sets, but in certain level you want to standardize also a bit. And it's also the advantage of how advanced is the team. You know, if you got really good diehard DevOps programmers, they work with the tools you throw at them. If you have to start learning with one, I would say make a good do your requirements and make a selection of it.
Yeah, that makes sense, and that's what I experience as well. That for me, it's easy to adapt to a different scripting language or a different declarative language. But yeah, for those that are just doing their first baby steps, then it definitely helps to already have a standardization and a tool selection pre-selected, instead of basically having them have to figure out how many different languages and tools they have to master. So thanks for that answer. So, Roel, do you have another question?
Yes. Last month we had a speaker who had a very specific preferred feature of Azure DevOps pipelines, and I was wondering if you had any favorite features of that as well.
Of Azure DevOps pipelines? Good question. I don't have found one yet, and if the Azure DevOps pipeline doesn't support something, I just build it myself in PowerShell and output it to the pipeline and use it again. So I don't have a specific feature I'm using there.
And the multi-stage pipeline what we're using with the approvals and all the flow attached to that and integrate with ITSM, that's something I see as a really good added value. But like Patrick said, if the feature is not there, then we'll find a way around to get that integrated anyway. So, was there a specific feature he mentioned that you can share with us?
I'm curious.
Yeah, you make me curious.
Yeah. Last month it was the templates feature. So being able to template stuff out and reuse it multiple times in.
Okay. Yeah.
But basically, we are also doing that with the ITSM changes. There's our Cloud Competence Center created a template of it, so we can just use it in our pipelines by just specify some parameters, and then you can log or close a change. So that's an awesome feature.
Can I do one more, Esther?
Yeah, sure. Go ahead.
All right.
I'm learning new stuff too. So
I built a couple of pipelines as well, and for me, debugging them can be a real pain sometimes, because sometimes your fifth step in a pipeline, which takes 6 minutes, fails, and you still need the other 4. So, are there any tips you guys have for debugging while building pipelines?
Good question, and maybe for the infrastructure as code, and maybe that's a common tip or advice. If you're starting with it, just run it first from your laptop. And as I mentioned with Packer, and another guy was giving a great tip, if you want to try your build and it fails there, you can just install VirtualBox for free on your machine, run Packer without a pipeline, and just see if your task sequence is working, and you can troubleshoot it very quickly. And if your Packer template is right, then put it in the pipeline, and then the first step will automatically be succeeded, and then focus on the next step. And sometimes I'm trying also to make multiple stages, so I can reschedule the second stage. If you schedule a pipeline, you can just skip the first stage, and if you make the second stage not that dependent on the first stage, or give some parameters to the second stage so it can reuse the thing which succeeded in the first stage, you don't have to wait on the first stage all the time.
That's an awesome tip. Thank you very much.
Yeah.
You're welcome.
So I guess this means, due to the time, I just want to say thank you very much, guys, for sharing your experiences and the tips and tricks that you discovered, adapting to an Azure DevOps, a CI/CD way of life, so to speak. And I guess there's still room for like a quick bio break, and then please come back as soon as you can to join us with the next presenter.
Thanks for having us.
Yeah, thanks for having us, guys, and girls, and have a great evening.
Thank you, guys. Here we are again. That was the fastest bio break in recorded history.
Yeah, I'm lucky the bathroom is not all the way across the house, so I only had like a small run to make. So yes, we made it.
Okay, so the last session was your expertise. Now we are moving on to my neck of the woods. So I would like to introduce Purnima Nayar as our next presenter. Let's see if she's here.
Hello.
Hi.
Hi, good evening.
Good evening.
How are you doing?
I am well, thank you. How are you?
I'm well as well. Esther is relieved. So
I do apologize for that. I didn't know that it would become so hectic. I thought I had all the time in the world.
all right, Purnima, welcome.
Thank you. Pleased to be here.
Yeah, it's very nice to have you. So I won't take up much of your time before you can start your session. I just wanted to ask, you've been speaking in public for a while now. I was wondering, since you are an MVP, and I am guessing people are watching who also want to start speaking in public, how did you get started with it?
Good question, actually. So I am a part of Umbraco community as well. Umbraco is a .NET-based open source CMS with a very active community. And I was invited as a speaker to the German festival back in 2019. So I presented for the first time there. And then I decided that this is something I want to continue doing. And then I started talking tech. Actually, my first talk was not a tech talk. And then I started doing tech talks, and I decided, yeah, this is something I want to do. Being on stage is not a new thing for me because I am an artist as well. I'm someone who is training to be a singer as well. So being on the stage is not a new thing, but being on the stage singing and being on the stage talking are two different things.
Okay, so now I have to ask, what kind of stuff do you perform?
Okay, so I am also a student at the moment learning Carnatic vocals. So Carnatic music is a stream of Indian classical music, and I've been a student for the past 3.5 years. Although that I have done few years in my childhood and teens as well. So I am working towards my first stage performance, hopefully in a couple of years from now. That'll be like a proper traditional kind of concert.
Wow. Oh, then we definitely need to have you back and just create a whole new life after Azure theme show, probably. Because I love discovering not just the technical knowledge, but also the persons behind like what you like and what you do to relax. So this is awesome.
Yeah, absolutely. So when I'm not thinking about code, I'm either with my daughter or I am working on my music in my head.
That is amazing. Yeah,
It
I
just
know
keeps me
how I
going.
sound in the shower, so I will not put you on the stand because I know from my personal experience, some things you need to keep private. But yes, I just love to discover the personal side. Awesome.
Brilliant.
All right. So
And I was
wrote it
already
down.
excited to learn a lot more about Azure Static Web Apps. So I guess we can definitely zoom in on the singing. But basically, I'm very excited to learn new technologies and new Azure services. So I'll just try to shut up and let you get started with the presentation.
Absolutely. Thank you. So let me share my screen to begin with. Screen 3. Hello, and pleased to be here. Thank you for having me at Azure Thursdays today. I'll be talking about Azure Static Web Apps. A little bit about myself before we start off. I'm Purnima Nair. I'm a freelance .NET developer based in Berkshire, UK. I'm a Microsoft MVP for developer technologies, and I have also been an Umbraco MVP for the past 3 years. For those who don't know Umbraco, Umbraco is a .NET-based open source CMS. Known work me, I think you just knew about me, but reiterating it, I'm a mummy to a nearly 7-year-old girl. I spend a lot of time reading. That's my winding down process. And of course, there is Carnatic music, which I am a student of as well. Let's talk about modern web app development for a minute before we talk about Azure Static Web Apps. So these days, there's a whole focus on static frontends and serverless APIs. When I mean static frontends, there's HTML, and of course, there's the whole new realm of JavaScript libraries like Angular, Vue, React, all talking to APIs and web apps based on those. There's also the whole new realm of static site generators. And things are getting more exciting with powerful modern browsers that support WebAssembly. And that has made .NET to run on the browser with Blazor WebAssembly. So very exciting. So now let us consider an ASP.NET MVC traditional app. What it is doing is two different things at any point of time. It's doing all the heavy lifting that an API can do. And at the same time, it is also serving static content like HTML, JavaScript, your imagery, all of that. So, so there should be a way to make this much better for sites or apps where static frontends and APIs are used. And that is the whole thought process behind Azure Static Web Apps. So Azure Static Web Apps is a complete hosting platform, as Microsoft says it, for full stack apps with static or pre-built and pre-rendered front end, and with the option of having an API, a serverless API backend. It's a turnkey service, and it has two parts. The first part is the app itself to serve static content, and the static content is served through globally distributed locations. And you also have the option of having a serverless API powered using Azure functions. Both are part of the same app. So it's like a package. The fun fact is, because the app is always served from the nearest location to the user, it is performant. And so it is doing what it is supposed to do. That is delivery of static content. So which means it's optimized for content delivery. And of course, we have the API support using Azure functions, which means that it can scale on demand as well, which makes the platform quite performant. And the ideal candidates for static web apps or SWAs are Blazor, WebAssembly-based Blazor, Angular, Vue, React, JavaScript libraries, or even static site generators like VuePress or Gatsby.js. Now, you might be thinking, why Azure Static Web Apps when we can achieve the same using, say, Azure Storage? There are some standout features which makes it which makes Azure Static Web Apps have the edge over Azure Storage. The first one is GitHub and Azure DevOps integration. There's first-class GitHub and Azure DevOps integration. We'll have a look at it shortly. There's globally distributed static content. Content is always globally distributed and served from the location closer to the user, which means it's always performant. Free SSL certificates and support for custom domains, and that's Apex domains as well. There's managed authentication provider integrations. We will speak about that shortly. There's customizable authorization role definitions. Again, we'll look into that shortly. Routing rules, as well as integrated API support, all of which we will cover through in my session. Now, I'm a developer, and I would really like to know what I get when I use Azure Static Web Apps. From Microsoft's perspective, static web apps are a complete solution starting from local development to hosting. And there's also a workflow attached to this whole process, which is very, very similar to a developer's daily workflow. Let's see what happens in here. In a nutshell, a developer can check in code, and that triggers a deployment. The deployment is both the API as well as the static content, because both are a part of the same app. Now, if you are wondering, hey, that's not very flexible, I need the flexibility to deploy the API separately as well as the static content separately, hold your thought for a moment. I will come back to that. Now, let's have a look at this in greater detail. Azure Static Web Apps is pretty opinionated about where you store your code at the moment. So it can be GitHub or Azure DevOps at the moment, and there's first-class integrations to both these Git repositories. The Azure Static Web App, when you create one, it's tied up to Azure DevOps repo or a GitHub repo, and then it kind of watches a branch, say the main branch. When a developer checks in code to the main branch, a GitHub action is triggered or the pipelines are triggered, and that deploys your code into the Azure Static Web App, both API as well as static content. Now, if there is a PR raised against the main branch, that is also triggered. That also triggers a deployment and deploys to a staging environment. We will see that shortly as well. But in a nutshell, you can check in code and deploy that. We also get staging environments to preview our work if you want. And out of the box, the build process understands what is needed to build and deploy most of the frameworks and libraries out there. So that is all covered for you using GitHub Actions or pipelines. So as a developer, I can worry less about the DevOps aspect of the whole process, and I can focus on what I'm good at, that is code. There are two hosting plans with Azure Static Web Apps. The first one is the free plan, which is a personal, which is used for personal or hobby projects, or that's what Microsoft says we should use it for. And then there's a standard plan, which is used for production apps. Both free plan and standard plan get all the advantages of first-class integrations with GitHub and Azure DevOps. It gets free SSL certificate, the CDN, the custom domain support. All of that is there in both free and standard. But where this differs is these 4 points. The production app has a bigger size. Production app, I think, is 500 MB compared to the 250 MB for the free one. For the production app, we get more staging environments. I think we get 10, whereas we get 3 concurrent staging environments for the free one. With the standard of the production app, you have the ability to bring your own Azure function. So at this point, you can tie up your own Azure function to your static web app. And at that point, managing the Azure function, deploying the Azure function is your own responsibility. You can have your own pipelines for it. The code check-in and deployment will only happen to the static content from there on. And then you always have, you can also have custom authentication providers with the standard of the production app. With the free app, I think it's Azure AD, GitHub, and Twitter that is available. If you want to bring in your own authentication providers like Apple or Google or Facebook or a custom Active Directory tenant, you need to have the standard plan for that. And there are certain tools available to make lives easier for developers as well. There's a whole host of GitHub starter templates. So if I show you where it is, it's in this repo called Static Web Dev. There's a whole host of repositories, which are like GitHub starter repositories or template repositories. And there are starter repositories for many of the known frameworks out there, including Blazor. My demo is based on Blazor today, so I'll be using the Blazor starter. And there's also this curated list of resources, which is absolutely awesome. I have included a link to this in my resource list as well, so feel free to have a look later on. So before we go any further, let me create my own repo for this. Using this template, I am going to create a repo called Azure Thursdays Demo. I'm going to keep it private for the minute. So that creates a repository for me in my account, which I can always check out. So let me get that checked out as well while we talk about the next tool, Clone Repository. Oh, it's picked up the wrong repository for some reason. Clone git repository. Purnima Naya / Azure. Come on. Azure Thursdays demo. There we go. So that must be checking out. Yeah, there's also a very custom CLI tool that Microsoft has put together to emulate the cloud environment locally. So this is termed as a complete local development tool because it emulates the cloud environment on the local machines for us. So it needs Node.js to run, and it is installed using npm install as well. And all the documentation is available here in the GitHub repository. It's given in pretty detail, so you should be able to get started. What it does is it creates a reverse proxy locally for us. And we have 3 servers. The first one is the static content server. Then there's the authentication emulator and the functions core tools runtime. And the reverse proxy is at the heart of this entire CLI, and it routes specific requests to specific parts of the package. So /.auth is forwarded to auth emulator, /API goes to the API function, and everything else goes into the static web app. So if you need to test routing rules, or if you need to test your authentication rules for specific routes, then you have to have this tool locally. You can, by all means, run your Azure functions and your app concurrently, and you can test your work. But if you want to actually emulate the cloud environment and test the routing rules, then this is the tool that you need to go for. And finally, one more tool is the Visual Studio Code extension that we have, called Azure Static Web Apps Visual Studio Code extension. Again, this is something in preview as well. What this helps me do is create and manage a static web app from Visual Studio Code. So in my first demo that I have for you today, we'll use this starter template that I just checked out. It is based on a REST API, a very simple REST API function. We will use this particular Visual Studio Code extension to create an Azure Static Web App and deploy that all the way to the portal. So I should have the clone repository here. So it has got 3 folders. The API folder, which contains the weather forecast function. It gives me random results. Then there's the client folder, which is the Blazor WebAssembly-based project. And then there's a shared project for the models. And then another thing that you need to note down is that the API project is .NET Core 3.1 based. At this point of time, managed API functions, which are like the API function that is part of the package, can only support .NET Core, Node.js 12, and Python as well. You have to bring in your own function in a production app if you want to have .NET 5 based Azure functions. Again, the Blazor project in the starter template is pretty old, but I know that there's a pull request in place to kind of modernize it and bring it up to .NET 5. So let's have a look at the local CLI tool first and see what happens here. So with the local CLI tool, I can run the Azure functions and the app all at the same time and emulate the environment completely. So let's have a look at the app itself. The command for it is swa start. I need to use my local development server for that and get it running for that, first of all. So I use localhost 5000 because Blazor runs on this port, or .NET Core runs on this port. And I need to run this .NET watch run. I also need to run my API. So I'm sorry, API. Let me just clear this up. There's one mistake I made here. Before I run this, I need to get into my client folder and then start from there. So swa start HTTP localhost 5000 --run .NET watch run --API, and then the folder path to my API folder, which is one level up. So this should start everything for me, hopefully. Okay, now if I go visit my browser, localhost 4280 is the port where it all runs. It is thinking something, and yay, I have my app. So it's based on the Blazor starter app that you already get as a part of Visual Studio template. As you can see, this is not loading because of certain course issues. So let's stop this and let's see what's happening. So I'm happy that mistake happened. So in the local settings example.json, there is this course credentials and the course rules that's been put in. And it says in the repository itself that it needs to be done. I need to change the local settings example.json to local settings.json. It's one thing I always forget. So let me rename this and then start again. If I'm already browsed to 4280 in a browser, it might actually lock everything up. So I have closed all my browser tabs. It should run now and give me some result. Let's just go and do it now. Oh, yeah. Keeps jumping. I don't know why. First start http://localhost 5000 --run .NET watch run. We'll try for one more time before I move on. Okay, that should be it. 280. There we go. That is the data loading from my weather forecast Azure function. Now let us try and deploy this all the way into an Azure resource using the extension that we have. So I have installed the extension and it's all, and I'm logged into my Azure portal as well. So I can use the extension and this icon here to create a static web app. So it's asking me to commit something, which I am committing, yeah. So now it has started giving me alerts. So I need to first enter a new name for the Azure Static Web App. I'm going to go with the defaults. It's now going to ask me about the build preset. I'm choosing Blazor, and that is how it understands the build process that it needs to undertake. The next thing it asks me is the location of the application code, and this is where the app resides. And for me, the app resides in the client folder. The next thing is the build output folder. So this is where all your static assets, including imagery, the HTML, and the JavaScript resides. For Blazor, it's the www root folder. So I'm going to leave that in here. And that creates the resource group, creates a resource, deploys that resource, and also deploys the code for me. What it also does is a git pull, if you might have noticed that. And the git pull is because in the git repo that I've just created, it goes in and adds a GitHub action. And this GitHub action is responsible for deploying my code to the Azure portal resource that it has created. Let's go and have a look at the action itself while the work is in progress. there are 2 jobs in this GitHub Actions, and it listens to the branch main because that is where it is all tied up to. And every time a pull request is opened, synchronized, reopened, or closed, it listens to that branch as well. There are 2 jobs, build and deploy job and a close pull request job. What happens is with the build and deploy job, the work is deployed to production. The most important things to note here is the app location, which is the client here, which I've said that is my client because that's the folder which holds my app code. The app location is the location of the app folder. The API location is the folder in which the API code resides, and the output location is actually what serves the static content out. In my case, it's www root. With the close pull request job, again, it keeps a watch on it. It deploys a staging environment. Sorry, not with the close job. Whenever a close pull request is executed, it deletes the staging environment for me, as well as deploys to the production for me. That's what happens with the GitHub Actions. So let's go and have a look at the GitHub Actions itself and see what's going on. It's still deploying the resource. It's deployed the resource. It's deploying the code for me now. Let's hope that it succeeds. Let's go and see whether anything is deployed. It's still waiting for content. Meanwhile, let's go and have a look at the resource group it is created and the static web app and see what is in the various different blades. So this is the static web app in the Azure portal. And as you can see, it has got a source branch it is tied up to. In the configuration blade, you can have any app settings that you want. If you have a function that talks to a database, you can have that app setting here. You can enable application insights. Custom domains can be managed from here. And this is where you have the Azure functions. It's very subtle. You cannot do much with it because you cannot manage it. It is managed by the service for you. Here you can see the list of environments. I only have a production environment. If I have a pull request open, I will have a staging environment as well. The role management screen is quite an important one because this is from where you can send invites to user for inviting them to app. And the whole plan gives away the information about the app itself. So let's try and refresh and see whether anything is happening. It's still in progress. Let's keep a watch on that and move on to the next slide. Let's talk about API support in Azure Static Web Apps. With Azure Static Web Apps, APIs are completely optional. So theoretically, you could have a Blazor app or any app which talks to a completely third-party API, which is of interest for me again, because I do a lot of work with Umbraco headless and connecting Blazor apps to Umbraco headless CMSs. So that is something that is like a perfect candidate for Azure Static Web Apps. With APIs, there are 2 configurations. There's the managed and the bring your own. The managed is where it is a complete part of the package. And it is available for both the free as well as the premium production plans, premium hosting plans. With bring your own, that is available only on the production or the standard hosting plan. But if you bring your own, you can have your own deployment plan and everything for that Azure function. And managing that Azure function is your responsibility from there on. There is something that you need to take care of while you have your API, regardless of whether it's managed or bring your own. The API root is prefixed to /API. So /API /something is where your APIs would listen to. And in the production environment, it is served from the same origin as the app using a reverse proxy. So CORS is never an issue when it gets to the environment. And the authentication and authorization for the environment is very strongly tied up to the environment itself. And as much as the app has got access to the user information, APIs have access to the user information as well. There are certain catches as well with API support. Managed functions only support Node.js 12, .NET Core 3.1, or Python 3.8 runtimes. And it's only with bring your own that you can have, say, a .NET 5 based Azure function. Logs are available only if you enable application insights, and there's not much room which you get with your routing rules with APIs. You can only use routing rules to secure your APIs down. And managed functions only support HTTP trigger. So there are certain catches as well. Now let's go back and see whether whether the action is deployed. So it's deployed now. So let's go and refresh the app. So that is the app here. If you look at weather forecast, let me just refresh it. As you can see, it's getting served from the same domain, and the endpoint is /API/weather forecast. Now let us make a very small change to my app and try and commit it to another branch and see what happens. So let us create a branch, test branch, very good name for the branch. And then in my pages, say, hello Azure Thursdays. Let's commit it and push it. Again, fantastic messages, I would say. I'm going to push this branch up to a new upstream branch. So that's gone in. Let's go have a look. So it's asking me to create a pull request. I'm going to create a pull request. Now I'm going to just leave the defaults in there. So it's ready to be merged. And let's see what happens in the action. As you can see, the app is looking or watching over the main branch. And every time a pull request is created to the main branch, it triggers another deployment. But what this will be doing is creating a staging environment for me and posting the link of that staging environment back into my pull request. Let's wait till that runs. But meanwhile, we'll carry on and go forward with the slides a bit more. Let's talk about application configuration now. Application configuration like routing and fallback routes, a lot of that is managed using a very powerful file called static-web-app.config JSON file. So I think previously when static web apps as a service was in public preview, the file was called routes.json, but now it is called static-web-app.config.json. And static web apps, SWAs expect this file to be in the app folder, that is the client folder, at the root or in its subfolders. The file is a very powerful one. It controls a lot of things. It can control routing, fallback rules, and much more. And there's also an overlap between the config file routes and authentication and authorization as well. So some of the things that you can do is redirects. So you can redirect one path to another using the routes. You can have rewrites. You can have headers attached to routes. So you can have global headers for the which is passed with every response, or you can play with a single response using a routing rule. If you are using the same header both in global as well as a specific route, then make sure that the global headers come first and the specific ones come later on, because the position of the routing rules also kind of makes an importance in this case. So I try to play with the cache control here. I wanted to have a cache control caching time of like 2 hours on the entire site, but on a certain route alone, I wanted like 1 hour. So I had to put my global headers high up in the hierarchy of the page and then have my more specific route later on, so that would take effect. So just have that in mind while you do that. You can also have navigation fallbacks. These are particularly important when you have single page applications like Blazor, which makes use of client-side routing. So if you deploy a Blazor app without the navigation fallback, what happens is if you browse to a route directly that's being served by the Blazor router, or if you refresh a page, what the static web app will try to do is it will try to serve you a static content of the same file name. So it might try to find a counter.html or a fetch data.html, and it might not work. The way Blazor works is every request to a Blazor app goes into the index.html in www root folder. So we need to have a rewrite in place so that every request to the Blazor app hits the index.html. The index.html is here. And it's a very powerful file because that is where you have the app component in Blazor. And this app component in Razor is what has the router in it and manages all the routing for you. So we need to make sure that there's a rewrite in place for this. And you can also exclude certain parts from the rewrite, like images or CSS can be excluded as well. More things that you can achieve with the routing rules is response overrides. You can create, in my example, it's serving up custom error pages. And you can also whitelist IPs if needed. So let's go back to the deployment and see how it is in progress. So it has actually deployed something. Let's go back to the pull request and see what's happening. It's posted a link for me in here as a comment. So this is my staging environment. So that is a different link, as you can see, and it says Azure Thursdays. Now, if I go back into my portal and look at my environments, that test branch is in place for me. Now, if I go back and close that pull request, it merges this into the main, deploys that into production, and deletes the staging environment as well. So it kind of maintains itself as well. So let's move on now to security around Azure Static Web Apps. Security, that is authentication and authorization, is kind of really tightly tied up to the platform. We have access to a series of pre-configured providers like Azure AD, GitHub, and Twitter. And the way users get access to an authenticated app is via invitations only. So in the role management screen, I can invite someone if needed, and the authentication providers I have is GitHub and Twitter, with a Facebook and Google preview as well. And once logged in, users belong to both authenticated and anonymous, authenticated role. And by default, everyone is anonymous. You can create your own role names if you need, and that can be specified here. If you want custom roles to be created and you want to skip the invitation process, the only provider that can take care of that for you is the Azure AD provider with a custom tenant. None of the other providers, or even being in a production plan, cannot skip over the invitations because users join only by invitation. The only way you can have a custom registration process is through a Azure AD provider. And the way the authentication is controlled on a route basis is through the static web app config JSON. I'll quickly show you how the route rules look like for this. So in the static web app config, I can define routes. So this is a rewrite. Let's just get rid of this. I don't have this route at the moment, so I'm going to just say allowed roles. And then I can say authenticated is allowed, admin is allowed, etc. And of course, you need to have users in the admin role as well for allowing access to this particular route. There's a system folder called /.auth, which is used for all authorization-related APIs. I would have loved to show you a demo of this, but we can see whether there's time for a demo later on in my session. But just moving on. To get the user information from the authentication provider, you can get that using the client principal data object. So the client principal data object can be obtained using a GET request to the API endpoint /.auth/me. Again, it's a very fixed endpoint, regardless of the provider you use, and /.auth/me is the endpoint that you get the information about the current logged in user from. So if there is no current logged in user, the object would be null. And this is for the app. And if you want to get the user information in your API, there's a request header for that called XMS client principal, which gives you access to the a base 64 encoded string containing the JSON object. So that is about authentication and authorization. Now let's take a slight detour from here, because the second demo for my day is around GraphQL and how we can have a static web app with a GraphQL function deployed into the portal. So what is GraphQL? It's a query language for APIs, and it's supported by a runtime for fulfilling those queries. And the most important thing is that GraphQL does not have any particular, or it's not particular about where your data resides. All of this query language and the runtime for fulfilling those queries, it's all based on your existing data. GraphQL is one of the very cool kids on the block when it comes to talking about APIs. And all GraphQL is a query language and a runtime which understands that query language, parses it, and serves you the result. In a nutshell, what GraphQL is specifying types and asking for specific fields on those specific types. Some features about GraphQL, it is strongly typed. At the heart of every GraphQL endpoint is something called a schema, and schema is made up of types. GraphQL is a specification, so it's like a contract or a blueprint. There are many different implementations of GraphQL across various different programming languages and frameworks, and each of those implementations tries to fulfill this particular specification. GraphQL is introspective. Now, that is a very interesting feature of GraphQL, because a GraphQL endpoint can query itself to understand more about itself. And this feature has given rise to browser-based IDs and standalone IDs, which are used for testing and a lot more, syntax highlighting, etc. We will have a look at it later on. I've got a sample for you on that. GraphQL is hierarchical. So if you consider your, say, database or a collection of data entities, they are all related, and that can be visualized as a data graph. What GraphQL helps you is extract parts of that data graph, which is the reason it's called GraphQL. And objects have relationships, and GraphQL respects that relationships, and therefore is hierarchical. And what you get back from a GraphQL query is a JSON response that mirrors the query. Again, I'll show you that in a moment. GraphQL is an application layer, so it comes somewhere in between your app as well as the existing data. So all GraphQL is interested in is getting your query, understanding it, reaching out to where your data is, and massaging it and giving it a shape that you asked for. It doesn't concern itself about where the data resides. The data can come in from a database of any type, SQL Server, Oracle, MongoDB, Cosmos, any of that. It can even be another REST API service or even another GraphQL endpoint itself through something called schema stitching. GraphQL is version free, so we don't have any hassle of versioning with GraphQL. This is because client or the consuming app and the API are very loosely coupled when it comes to using GraphQL endpoints. With clients that consume GraphQL endpoints, the client is in charge of what they want, to ask what they want, and they get exactly what they want. So we have a loose coupling between the client and the API, which means that the client and the API can iterate and develop at their own pace. The only time you can break that correlation between the client and the API is if you delete a field of the endpoint or if you change the nullability of a field in the endpoint. So GraphQL is version free, and if you're thinking versioning with GraphQL, you're probably approaching it in the wrong way. And GraphQL is finally transport layer agnostic. GraphQL over HTTP is the most popular way of doing GraphQL and consuming GraphQL, but GraphQL can be consumed and consumed across TCP, gRPC, and so on. GraphQL schema is what is at the heart of GraphQL endpoint, and it's made of types. So we have object types in GraphQL schema, which is representation of real world entities, like say a book and an author, which you can query or get information about. Then you have queries, which are the operation types in GraphQL for getting or reading data. Then you have mutations, which is the operation type for inserting, updating, or deleting data. And subscriptions, which are operation types for pushed updates. And all of this makes up the types in GraphQL schema. So the most important thing to understand here is that object types, queries, mutations, and subscriptions all are types in a GraphQL schema. And types are made up of fields, with each field having a name using which we can query the field. You have a scalar or complex type to which the data resolves to. And then you have resolvers, which resolves the field into the particular data type. And with any implementation of GraphQL, you are creating the schema and specifying the fields. Today, I'm going to use Hot Chocolate, which is an implementation of GraphQL in .NET. It's an open source GraphQL server for .NET. And I'm going to be building my GraphQL endpoint using Hot Chocolate, which is a package. And I have installed the 3 packages into my API function. What I have here is a Visual Studio solution with an API and a client folder. Now, I haven't made use of the starter template for this particular demo. I just wanted to see what it takes. I have a .NET 3.1 based API here, and my Blazor app is .NET 5 based. And there are 2-3 things I had to add. The first one being the local settings.json to get to have the course rules in place. Then I have my static web app config in my client for the navigation fallback. And in my app settings development, I have the base address for my Azure endpoint, Azure function endpoint local, which is localhost 7071. So let's start with the Azure function itself. So I've got Hot Chocolate ASP.NET Core installed and the Microsoft Azure Functions extensions installed because I need to inject some middleware into the pipeline. And I've also got this package called Azure Functions Proxy. Now, this package gives the middleware for Azure Functions. And what that middleware does is when the request comes in, it parses the request and then forwards that to the GraphQL executor pipeline. So it's basically the middleware, the pipelines that you have in place. And once I have installed it, in the startup, I have registered the Azure Functions GraphQL into my services. I also have a book repository here, which gets me a list of books or gets me a book by its ID. And I've registered that into my startup. This one we will talk about in a bit. So what I have today as an API is an endpoint which gets me a list of books. And the models behind the scene is a book, which is a plain POCO class with ID, title, and an author. And I've also got the author, which is an ID and the name. Now, these are plain POCO classes. I need to let the schema know that such models are available, and I am going to create object types for that. And for that, I have this book type and author type corresponding to my POCO classes. So the way you start off creating an object type is inherit from the object type class and give it my base source or base class, which is book. And then I can override and configure it. This method helps me override the names or the field type or the description that I have. So there are a couple of ways of doing this in Hot Chocolate. I usually go for this particular way of doing it because then I can make it clear to the attendees that this is an object type and types are which makes the schema. So for each of the field in my POCO class, I have added some overriding. I've got the field name overridden and everything is in lowercase now. I've also added descriptions. And these are very useful because it gets picked up as documentation in the browser-based IDEs. And I've also got the returning type for each of these fields. The last one is of particular importance. It returns an author type. and that is because my book class, the book author is an author type, and I've got a corresponding object type for the author as well, which with each of the fields overridden with their own types. So that is the object types. Now for the query, which is the root operation type, I've got a class here called query, and I've injected the book repository into it, and I've got methods for getting a list of books or getting a single book by its ID. Now, I need to register this query as a type in my GraphQL schema. And again, for this, I've got a query type, which inherits from object type, passing in the query. Again, I can override the field names in here. And in the second case, where I'm getting a book, I also need an argument in place so that I can pass in the ID that comes in from my query. So that is the query type. Now I can register that query type in my startup function. I need to first add the GraphQL server so that the GraphQL server itself is up and running, and I can add my query type. You can add query type extension method and register and give it the type as well. What this in turn will do is it will go and register all the corresponding types that it is talking to. That is the book type and the author type. The most important thing to understand here is that the query type is also a type in GraphQL, and each of these are fields. So get books, get book, they are all operations, but they are fields in the query type. With GraphQL, it's important to test your queries, and for that, we have IDEs. They can be browser-based or standalone ones. The IDEs helps with syntax highlighting, IntelliSense, error highlighting, and a lot more. And one of the finest features about GraphQL is schema introspection, because these IDEs make use of the introspective feature of a GraphQL endpoint to have up-to-date documentation. There are many, many IDEs available out there. Sorry, I skipped a slide. Graphical, I think, was the first one. Then you have GraphQL Playground, and all of these can be baked into your GraphQL endpoint itself. Most of these are browser-based, except for Insomnia and Banana Cake Pop. Insomnia is standalone desktop app. Banana Cake Pop is again from the house of Chili Cream, and that is where hot chocolate is from. Banana Cake Pop is standalone and is not open source, but I believe that one of the upcoming release, or probably the release that we have right now, you can bake in Banana Cake Pop just like you would have a graphical or GraphQL Playground as a part of your endpoint. So I've got, let's start my Azure function and the app. And this is Banana Cake Pop. We have the ability to refresh the schema, reload the schema, etc. And what it does is it reads the schema and generates that in a much more readable fashion for me here. So if I go into get books, I can see that it is returning me a list of book types. So the square brackets mean it's a list in GraphQL. And I can click through each of the field and understand what each of the field is all about. So if you have a big GraphQL endpoint, this can be extremely useful. And not only to the fields in the object types, you can have descriptions to each of the methods as well. So I can actually add a description to each of the operation in the query type and get that out here for the end user who is using it. So I've got some queries in place. The way you start off GraphQL queries using a query keyword, you give a arbitrary name for your operation, and then you can start using the actual field in your query type, which is get books in my case, and I can ask for specific fields. Now, if I execute this, it gets me a list of books. So it is only getting me ID and title because I asked only for ID and title. I cannot say, get me everything about get books. That just won't work, and it's already highlighting an error for me. Now, if I want to get user author information here, I have to start off with the author. And because it's an object type in itself, I have to then specify the fields I want. I can say author name and execute, and it gets me the author name as well here. But as you can see, what the response that I get here is an exact mirror image of my query here. Now, if you want to have an argument passed in, I again start off with the query and an arbitrary name. This time I'm using getBook and passing in, say, an ID of 2 and asking for the details. Again, I should be able to get the results here. There should be a variable dictionary here using which I can pass in GraphQL variables. So if you want to make this particular getBook more generic, I can specify an argument here, say $ID. This is how you specify a variable in GraphQL, and it's of int type, non-nullable. And then I can assign the variable value to my argument, and I can pass in the variable as a separate dictionary here, and then execute this. Should get me the same result. So that is our API up and running. We also need a client tool to consume this API. We can by all means use HTTP client. I'm using Strawberry Shake, again from the house of Chili Cream. What Strawberry Shake helps me do is generate strongly typed C# client from GraphQL queries. So I can take the GraphQL queries that I showed you and put that into a queries document. It helps me generate a strongly typed C# client for me. So which means that the result that I get back as a result of the operations, which is the data that you see in here, it's completely deserialized for me, and I only need to concentrate on the communication part rather than writing 1,000 different POCOs, trying to deserialize that properly for me. The setup notes are available here, but I'm not going to go into great detail about it, but what we start off with is a GraphQL client. You can add from here. You specify your endpoint, the client name, and the namespace. It downloads the schema, and then what I can do is start writing my queries in a GraphQL extension file. And for each of the queries that I have, each of the operations that I have, it generates an operation service in the client for me. So this is the generated folder which contains my client. So there should be an operation service called getBooks in my client. And each of those operation services has got an execute async method, which reaches out to the API and gets back the data for me. So I think my app is up and running. So in this component, I've got the data coming in from the API. So let's have a look at what is happening. The client, once generated, can be registered into the DI container. It's a named client that I get, and I am passing in the base address. The base address is the one I specified in the app settings development JSON for my local environment, or in the production environment, or when it gets to the SWA, is the base address of the host environment. I also need to append the API /GraphQL at the end, because that's how it reaches out to the endpoint. And I don't know whether there's a better way of doing it, but this is the only way I could get this working. There's one thing I missed out in the whole lot here, the actual GraphQL function, which is here, into which I've injected this executor proxy. And from there, the execute functions query async method is called, passing in all the details, which does the work of parsing the request and executing the GraphQL query and getting back the result. The route is set to GraphQL, which is the reason I have API /GraphQL here. And API is the root prefix needed for the API. So I've got the API as well here. Now let us try and deploy this into the portal. So now I'm going to start off with the resource here. I'm going to create a resource called static web app. Create. I'm going to put it in my existing resources, Azure Thursdays GraphQL demo. That's the name of my static web app. I'm going to select free as the option. I'm going to host it in West Europe. My code is in GitHub. So it lets me log in. I confirm the password shortly. I'm going to select my repository here. That's my repository. The branch is master. The build preset is again Blazor. The app location is slightly different in my case because I've got a very different name for my folder here, which is Azure Thursdays.graphql.swa, which I'm going to put here. The API location remains the same. The output location remains the same. I'm going to review and create the web app. I'm going to create this. What this also does is goes and creates a GitHub action for me in my GitHub repo. Did I do that? There we go. Actions. An action is already running, and it has created the workflow for me, which has got both the build and deploy as well as the close pull request job. And the action is running for me, so it should get deployed in a short while. Let's just wait and have a look while that is getting done. I think that is all what I had for the day. So while that is running, I can pick up some questions if you have any for me.
We do. But we were a bit mesmerized about everything you just showed us. So I totally forgot to write down any questions from the point.
I hope it was at a pace that you could understand.
No.
There's lots going on.
It was just from when you started with GraphQL, I was too focused to even write something down. But I did write down a question that might be quite clever about the static web apps. So is there any clear cutoff point where you would stop using a static web app and move over to app servers or something a little bit bigger in scope?
It depends really. You are the best person to kind of judge that, I think. For me, personally, the project that I kind of think about is Blazor with Umbraco Headless. And I see a lot of things in that community where you have Vue or Angular or React or Nuxt.js based apps which talks to these external APIs as well. And for me, those are the kind of perfect candidates for SWAs. Azure Web Apps, not at the moment, because if you are thinking about scaling, this is already scaled for me. I don't need to worry about that. With the API support, I have the ability to bring in my Azure functions. So at this point, as it stands, no, I cannot think of a particular point where I would switch from static web apps to app service. The only thing I could have said is about Blazor server, because being a SignalR service, it could have benefited from app service. But again, Blazor server is not the candidate. It's not a candidate at all for SWA because it needs server-side rendering. Any app, any web app which doesn't need server-side rendering is what SWA is suited for. And I believe this is a platform which is still being kind of developed and kind of, and it's very niche as well. So I believe you can ask for feature requests of your own as well, and Microsoft would probably listen to you because they want to see where the platform goes, as far as I understand.
Esther, do you have another question for Purnima?
Yes, I have. But first, maybe I need to explain that when I started in IT, I was building web apps with ASP.NET. So this is like a whole new world opening up to me. So I definitely need to study on the new technologies that are available. So thank you for getting me excited and eager to adapt the modern way of web apps. But I did notice during the presentation that a couple of times when you were referring to the relative paths for AUF and API, that it felt like you, and I'm trying to find the right words to phrase it, that you felt a bit disappointed that those are, that you cannot configure those relative paths yourself, that those are set. And coming from an IT background and security in mind, do you feel that that makes the static web apps more vulnerable for attacks, giving them a bigger emphasis on the need to definitely secure them better than having relative paths that you can configure yourself?
So the relative paths are only when it is on my local, I feel. When it gets to the server, the platform is all secure for you. There's a reverse proxy in place to talk back to your API, and that is one of the ways it serves it from the same domain. So whether it's your own Azure function or the managed function, it is protected for you because the reverse proxy protects it. Plus, you can add your own authentication to your API if needed using the routing rules. In fact, that is only one of the possible things which you can do with the API paths. So I think if you take care of the API aspect, API security aspect using authentication yourself, there's, of course, the platform helping you with the security as well. So I think we should be safe to do that. Yes, the / API is a bit, for me as a developer, there's no flexibility. But we never know, things could change in the future because, as I said, this is a platform which still Microsoft is kind of experimenting and trying to see what the community wants. And I believe, and I hope they would listen to us right now.
I'm confident that they will listen, but that's from my own experience with different engineering teams and interacting with them. They are eager to get the feedback and eager to address and make it even more user-friendly. So, yeah.
Absolutely, absolutely. For me, this is a very, very niche platform with a complete focus on just static content. So I'm quite eager to wait and see how this grows as well. Because there is MAUI coming up. There will be progressive web apps, which takes the form of mobile apps as well. So I am quite excited to wait and watch and see what comes out of it, how people experiment and come out with different ideas with static web apps as well.
Well, I would love to invite you back in a couple of months and see what the new feature set is and how we can even build more cooler apps. I might even throw in a demo myself, but I'll need some time.
I'm letting the cat out of the bag here because you and me know, like we all of us know, the talk I planned for the day was more Blazor focused with Azure Web Apps. But when I started kind of looking at Azure Web Apps, it was like, this needs to be a talk on Azure Web static web apps because there's so much fun in doing what I just showed you today. There's a lot of resources out there as well. So yeah. I had fun learning about Azure Static Web Apps as well. I don't use it personally, but I am also eager to learn new things. So all good.
Awesome.
Yeah, thanks so much.
Yeah, I guess on that note,
wait and see a minute whether the app is actually deployed, because that's it has deployed. So if I go into my portal and refresh.
Excitement.
I love the names that the static web apps give us. It's completely random. Yay! And that is data coming out of my GraphQL endpoint for my static web app. So that is the live demo done for the GraphQL endpoint. And that's my resources link if you want to share it with the attendees as well. Thank you so much for having me today. It's a pleasure to be here. Thanks a lot.
Thank you so much for being here. So Esther.
Yes.
We did it. We made it to the end.
Yes. So
we went 10 minutes over time, but it was totally worth it.
Of course, and we need to rebel every now and then. So I guess people might already expect some of these actions happening from us. I guess it's smart to mention to those of you who are still watching the stream and didn't leave us already that we will have a short summer break. So next month there will not be an Azure Thursday, but we will get back to you in September, bigger, better, bolder, with lots more fun presenters.
Yep, we'll make sure to update you soon on what we have planned for September. So for now, I think let's wave goodbye and go to bed.
Yes. Good plan. So have a great evening, everyone.
Bye-bye.